Right. Anyone need any bit of number 2 done? Second one, right? Okay. So number 2. So number 2 is solve. So it's z squared plus 4z plus 7 equals 0. So it's the minus b formula. So a is 1, b is 4, c is 7. So it's minus b plus minus the square root of b to be squared minus 4 times a is 1, c is 7, right, all over 2 times a, which is 2 times 1. So that's minus 4 plus minus the square root of, that's 16 minus 28, that would be 12? Does it work out to be 12? Right. Does it work out to be minus 12? It does. Yeah, all over 2 times 1. Right, okay. So it's just on the side, square root of minus 12 can be written as the square root of 12 by I, and square root of 12 is 2 root 3 I. Is that alright? Simplify it using your calculators into the calculator, it'll do it for you. Is that right? Okay, so that's minus 4 plus minus 2 root 3 I, all divided by 2. So divide each one by 2, so that's minus 2 plus minus root I. Is that okay? Right, and why they ask me this is because you can see that the roots are the conjugate of each other. One answer is minus 2 plus root I, the other answer is minus 2 minus root I. Sorry? Why I left a 3. Oh yeah, sorry, there's a root 3 in there. Apologies, there's a root 3. Oh, for God's sake, that's just so bad. It's root 3 I. I wrote root, the I is not under the square root sign. Yeah, sorry, I just, instead of writing root 3i, I wrote root I. It's just silly. Right, okay, so the I is not under the square root sign. Okay, so it's root 3i. Is that okay? Sorry about that, I lost the run of myself there. Right, okay, number 2. Anyone need any bit of number 4? Number 4? No, we're okay. Number 6? Yes? No? Yeah. So number 6. Okay, so number 6. Given that 2 plus 3i is 1 root of the equation, right? 2 times z to be cubed minus 9z to be squared plus 30z minus 13 equals 0. Find the other 2 roots. Right, okay. It's real, there's real coefficients, right? So that means the conjugate roots theorem applies. So if 2 plus 3i is a root, 2 minus 3i is a root. Okay? So you have 2 out of the 3. There's 3 roots. The other root is definitely what? The other root is definitely a what number? It's definitely a real number. Because cubic equations always have at least one real root. So when there's 3 roots, you have the 2 imaginary roots. So the last one is real. Right? So what you do is you get the quadratic, right, of the 2 roots you have. So it's z squared minus z times the sum of the roots plus the product of the roots. Okay, so sum means you add the 2 roots, product means you multiply the 2 roots. Z squared minus z times 2 plus 3i plus 2 minus 3i. And here, multiply them, so it's 2 plus 3i multiplied by 2 minus 3i. Okay, so that would be z squared minus z times, inside that bracket, you plus 3i minus 3i cancel, 2 and 2 makes 4. Right, over here multiply out 4 plus 6i minus 6i minus 9i squared replace the I squared with a minus 1. So that would be, sorry? Sorry. Okay, it's back. Z squared minus 4Z, and they cancel, that becomes a plus 9, so that's plus 13 equals 0. Okay, so then it's not equal to 0. Well, it is, it doesn't really matter. Okay, right, but what you do then is you take your cubic equation, 2z cubed minus 9z squared plus 30z minus 13. I'll do the division the way most of you like to do it, divided by z squared minus 4z plus 13. So z squared into 2z cubed goes 2z times. So 2z times, multiply 2z by z squared is 2z cubed. 2z by minus is minus 8z squared. And 2z by that is plus 26z. Okay, change the signs, that becomes a minus, that becomes a plus, that becomes a minus. They cancel, you have z squared minus 4z, sorry, you have minus z squared minus 4z minus 13, and z squared into minus z squared goes minus 1 times, so multiply there, that's minus z squared plus, what the hell, that's a plus 4z, thank you, plus 4z minus 13, change all this. Okay, so everything cancels, so there's no remainder, which you know because they've told you it's a factor. So the final factor is 2z minus 1 equals 0. Solve that, 2z is equal to 1, so that means z is equal to a half, and you already have your two answers from the top. 2 plus or minus 3i are the other two answers. So a half, 2 plus 3i, 2 minus 3i are your three answers. Is that okay? Right, 8. Anyone? Yes. Right, okay. 8, yeah.
Just with that question, could you do that with factors instead of that, like how the sum of products?
Say that, could you do it with factors? Yes, you could. I did it when I did my example yesterday. I did it with factors. Okay, so yeah, if you just want to look at the recording from yesterday, you'll see, or take a picture of. I did it out the long way, as I call it. So if you want to take the picture of someone's notes, you'll see you can do it with factors. Right? Okay. Right. 8 is next, which is 1 plus 2i divided by 1 minus 2i. Listen, I have to sort that out first. Okay, right, so you can't deal with that as it is. Right, so you have to do the division. Right, so that's a division, so you multiply above and below by the conjugate of what's below. So you're multiplying above by 1 plus 2i, and you're multiplying below by 1 plus 2i, because the conjugate of what's below is 1 plus 2i. So then multiply above the line. Right, I'm just multiplying out. You get 1 plus 2i plus 2i plus 4i squared. When you multiply out below the line, you get 1 minus 2i plus 2i minus 4i squared. Right, replace the i's with I squares with minus 1. So above the line, you end up with minus 3 plus 4i, because that becomes 1 minus 4, which is minus 3 plus 4i. Underneath the line, the i's cancel, that becomes a plus 4, so you end up with a 5. Is that okay? So you can split that up if you want. Minus 3 plus 4 over 5i. You don't have to, but right, okay. Is that right? So it says that's one root of the equation. So I have another root of the equation, don't I? Because they tell me A and B are real. So A and B are element of R, so that means the conjugate roots theorem applies. Right, so if that's one root, what's the other root? Minus 3 over 5 minus 4 over 5i. Agreed? So we have, this is one root, they told me, and this is the other root, right, because the conjugate root theorem applies. So it's z squared minus z times the sum of the roots plus the product so that means it's minus z times the sum of the roots is minus 3/5 plus 4/5 I minus 3/5 minus 4/5 I. The product of the roots is multiply those. So it's minus 3/5 plus 4/5 I multiply by minus 3/5 minus 4/5 I. Okay, so it's just a pain with the fractions. Okay, right, okay, so you get z squared minus z times, inside that, plus 4/5 I minus 4/5 I will cancel, minus 3/5 minus 3/5 is minus 6/5. Okay, over here, multiplying out, right, okay, minus 3/5 by minus 3/5 is 9/25. Minus 3/5 by minus 4/5 I is 12/25 I. Then it's plus 4/5 by that is minus 12/25 I. And then plus 4/5 I by minus 4/5 I is minus 16/25 I squared. Is that okay? You can replace that with a minus 1. Okay, so I end up with z squared plus 6/5z. And sorting out over here, they cancel, and that becomes a plus 16/5. So that would be plus 1. 9/25 plus 16/25 is 25/25, which is 1. Is that right? Equals 0. And then we want to multiply across by, find the value for A and B. You could give the answer as it is, right, okay, because they didn't say A and B were integers, were whole numbers. They said they were real numbers, so you could say as it is, you could say A is 1 and B is 6/5. Oh no, you couldn't, because they said, sorry, apologies, I'm just reading the rest of it, plus BZ plus 5 equals 0. That's the way they said it was in that form. Okay, it's nearly in that form. I have a plus 1, they have a plus 5. So what will I do? What I do, multiply across by 5. So multiply everything by 5. So you get 5z squared. Here, you multiply that by 5 and the 5 underneath the line cancels. And multiply that by 5 and you get 5 equals 0. So then A is a number in front of z squared, which is 5. And B is a number in front of z, which is 6. Job done. Is that okay? Ten. It's okay? Yeah? 12? Do it? Yeah, okay. Are we good? Right, okay, 12. Form a cubic equation with real coefficients where the roots are 2, so z equals 2, z is equal to minus 1 plus I, and I also have the third root, which is what? Minus 1 minus I. How do I know? Right, okay, because they told me the coefficients were real. Okay, is that right? So I have the three equations, right, or the three roots. So that was originally z minus 2 equals 0. This was originally z plus 1 minus I equals 0. This was originally z plus 1 plus I equals 0. Okay, so then they were 3 brackets, z minus 2, z plus 1 minus I times Z plus 1 plus I, right, equals naught. Now, you could do it, you could form the quadratic using those two and multiply your answer by Z minus 2, right, okay, or you could just do it like this, right, it really doesn't matter, right. So I'm just going to leave the Z minus 2 there a minute, if that's okay, and I'm going to multiply all of this, okay. So here, I'm going to split up that middle bracket, write this last bracket down twice, plus 1 times Z plus 1 plus I minus I times Z plus 1 plus I. Is that okay? So I just split up that bracket, wrote that one. So I'm multiplying these two brackets first, going to get an answer, and then multiply it by Z minus 2. Right, so Z minus 2 will be for a minute. Right, multiply in here. I have Z squared plus Z plus IZ plus Z plus 1 plus I, keep an eye on me now, minus IZ minus I minus I squared. Okay, so remember that's minus 1. Okay, tidying up inside the bracket, so I have Z minus 2 on the outside. I'll deal with that momentarily. There's only one Z squared. Z's are plus Z and plus Z, plus 2Z. Right, then I have an IZ and a minus IZ gone. I have a plus I and a minus I gone. And then I have plus 1 minus 1, which is plus 2. Agreed? Do you agree? Okay. Then I'm going to multiply that by that. So it's Z multiplied by Z squared plus 2Z squared plus 2Z plus 2 minus 2 times Z squared plus 2Z plus 2. That would be Z to the power of 3 plus 2Z squared plus 4Z minus 2Z squared minus 4Z minus 4. Okay, putting that together, I end up with Z cubed minus 4. Is that okay? Equals 0, which was your original cubic equation. Are we okay with that? I made a mistake, did I? Plus 4. Oh yeah, that should be 2Z. Z, what? Z by 2 is 2Z. Sorry, I was jumping ahead to the next bracket at my head. So that's actually wrong. So it's Z cubed. The Z squares still cancel. That would be minus 2Z and a minus 4. Am I good now? Right. Okay. Am I good? Everyone happy? Right. Polar form of a complex number. Right. Okay. Time. I'm okay. So, polar form of a complex number. Right. Okay. So we can call we can get the position of our complex number on the on a graph using x plus yi. So it's cross x up y. Agreed? Right. We learned how to do that. There's a second way you can record its position on the graph, right? And you need two measurements, right? So you still need two measurements for this. You need to know x and you need to know y, right? You can also record it, it's called polar form, right? If you measure the angle between the complex number and the positive x-axis. I'll explain what I mean by the positive x-axis. I'll stress that in a minute. But it's the angle between the complex number and the positive x-axis and the modulus, right? And the modulus we call r. So remember the modulus, the square root of a squared plus b squared, was the distance from the complex number to the origin. Okay, so it's just a second way we have of representing a complex number. So we can represent it as x plus yi, but we can also represent it, it's called in polar form, right, which I will get to in a minute. So I'll leave you write down the diagram and then we'll stop and we'll explain. So if we have sine of theta, so we have a right angle triangle here, don't we? So we have sine of theta. So what would sine of theta be equal to? Sine is opposite over hypotenuse, agreed? So what's the opposite to that angle? What is it? It's y. What's the hypotenuse in that triangle? R, which is the modulus. Remember, R is the modulus. It's the length of that line, which is square root of a squared plus b squared. I can rearrange that, girls. So I have y is equal to r sine theta. Right, cos of theta, cos of that is adjacent over hypotenuse, which is x over r, and I can rearrange that. So instead of writing x, I could write r cos theta. Now, r, so was the modulus, the square root of, that should be, sorry, a squared plus b, oh no, it's actually x squared plus y squared as well because of Pythagoras' theorem. Yeah, I'll just do x squared plus y squared, which is what I'd written down. Pythagoras' theorem will tell you r is equal to the square root of x squared plus y squared, okay? Which we know already to be the modulus. The length of the line from the origin to the complex number is the modulus, right? Theta is the argument, right? That's what we call the angle between the complex number and the positive x-axis. I stress positive x-axis. We'll see why in a minute, okay? Right, okay, so what I was saying was the complex number could be written as this in Cartesian form, right, or rectangular form, sometimes they call that. Cartesian or rectangular form, which is what we're used to, what we've been using up to now, okay? But instead of x, I can write r cos theta, and instead of y, I can write r sine theta. So it's just a different way of representing the same complex number. So it's x plus yi. And then I can just, there's an r common, I'll just take it outside the bracket. So it's cos theta plus I sine theta. I'll just put the I in front. Okay? And that's called polar form. Okay? So polar form is just a different way of representing the complex number. And girls, the reason why will become apparent in the next few sections. So there's a reason why we would express it in a different form. For the moment, we're just learning how to express it in a different form, but I will come to why in a while. Is that okay? Right? Okay, so sometimes we leave the why until, so don't be a 4-year-old and ask why, okay? Not now, not yet. Right? Okay, are we okay? Can I move that up? Right, you needn't write down the next bit, okay? But if I had a complex number that was here, right? R is the length of that line, or the modulus. This is theta, right? Okay, they're the two measurements I would have to know, right? If I had a complex number that was over here, right? Theta is that angle there, okay? and r is the length, is the distance from 0, to the point. Okay, so this would be theta. If the complex number on the graph was down here, right, look, the argument is all the way back to the positive x-axis. So it's all the way back to the positive x-axis. Does that make sense? So it's always back to, this is the positive x-axis, this bit here, right? So you have to go all the way back to that line, right? Okay? If the complex number ended up down here, the argument would be all the way back to the positive x-axis. Okay? Does everyone see that? So the size of the angle is all the way back to the positive x-axis. Right? Have we got that? Okay. Right, you needn't write that bit down. Okay. There we go. Rectangular form or Cartesian form. Right, so that's what they call x plus yi. So it's a rectangular form or the Cartesian form. Right? And the polar form is when the same complex number is written here, except we don't have the x-coordinate and the y-coordinate anymore. We know the modulus and we know the argument, the angle it makes with the positive x-axis. Okay, so remember when I'm talking about an angle and you get the sine, cos and tan of an angle. So if the words sine, cos or tan are written in front of the pi, pi stands for 180 degrees, not 3.14. So if pi is on its own, it's 3.14. But if pi is with sine, cos or tan, it's representing an angle, so the angle is 180 degrees. And we'll talk about that more when we get to trigonometry, but for the moment, just remember that. Okay? Okay? So, you know this, express, I'll wait for you to catch up and so you can listen. Right, express in rectangular form, right? Okay, so it's 4 times, right? We're going to change the angles to degrees. So pi over 2 actually stands for 180 over 2, doesn't it? Which is what? 90, right? Plus I sine of 90. Is that okay? Do you all see how I turn pi over 2 into 90? Pi represents 180 degrees because it's an angle. So 180 divided by 2 is 90. In your calculator, you get the cos of 90. So if you could get the cos of 90 in your calculator, that would be really good for me. 0, is it? 0? Is it? 0? Right. Can you get the sine of 90 then? I think it's 1. Okay. So that's 4 into 0 plus 1i. I by 1 is just I. Okay. Multiplying in, that's 0 plus 4i, and that's the complex number written in Cartesian form or rectangular form. Is that okay? So you just turn it from one form into another. That's what we're learning first. How do you turn it from one form into another? So going from polar form to rectangular form, you just get the cos or sine of whatever the angle is. Right? Is that okay? Are we good with that? Right, okay. So we're learning how to go from one form to another. So then, what if I start with rectangular form? How do I turn it into a polar form? Okay, I'm not going to get this done, but I can get it started. Okay, first thing you do is you do a quick sketch. So 2, 2 is across 2, up 2. Now, it doesn't have to be drawn out accurately, just so you know where in the diagram it is. Okay, so 2, 2 is here. Right? Agreed? I need the length of that line, don't I? Because that's R. Would you agree? How do I get the length of that line? Modulus. How do I get the modulus? It's the square root of a squared plus b squared, isn't it? So that would be the square root of, so this is R. R would be equal to 2 squared plus 2 squared, which is 4, 4, 8. 8. Square root of 8. 2 root 2. If you did it on your calculator. 2 root 2, sorry. Is that okay? So the modulus of that is 2 root 2. Right? The second thing I need for polar form, because I'm trying to write it in polar form, second thing I need is the size of that angle there. Okay? So the size of that angle there, it's in a right angle triangle. I'm just going to draw it out bigger. Okay, it's in a right angle triangle, isn't it? So theta is right here. This is 2 root 2. This is 2. This is 2. Yeah? Because it's across 2 up 2. Across 2 up 2. Yeah? Okay, there's your right angle triangle. So I need to know the size of that angle. So I can use sine, cos, or tan. Right? Doesn't matter which one I use. Why? Because I have the measures of all the sides. Right? So I'm going to use 10. So this is the opposite, this is the adjacent, this is the hypotenuse. So tan of theta is equal to over A, which is 2 over 2, which is 1. So how will I find out what theta is? Tan of theta is 1. How will I find out what theta is? When you're missing the angle, what you do? Shift and 10, don't you? Inverse 10. Shift and 10, 1. Right, so that will tell you, do shift and 10 of 1 there, please, for me. Was it? A quarter pi. Yeah, yours is, can I have it in degrees? It's probably, no. Yeah, I'd say your calculator's in radians. Will someone just do shift 10, 1 equals? Say that again? 45, thank you. I'll show you how to change your calculator back to degrees in a minute. Excuse me. Right. Okay. So in polar form, girls, that is r cos theta plus I sine theta. Just give me a minute. I just figured that r was 2 root 2. Cos of theta turned out to be 45. Plus I sine 45. Is that okay? That's your answer. That's it, written in polar form. Right, I'm going to ask you to have a go at page 28, 1 parts 2 to 4, and 2 parts 2 to 4. Because I've just done the part 1s. Okay, so 1 and 2, not the part 1s. Okay, so 1 and 2, not the part 1s on page 28. And I'll stick up a picture there now.